Okay, so hello. Let me make sure that the sound is going through. Let's just do like a little sanity check. Yeah, we're good. Okay, so today I would like to work on a drone, so just a drone sound. But I'd also like to use the opportunity working on a drone to show a strategy that I use with WAGs quite often, which is using primitive PureScript types. So one of the most important things for me as I was building out the framework was to go with the grain of a lot of the tools and useful abstractions that PureScript has to offer, rather than coming up with my own. So it's a mix of the two. But PureScript already has tons of really, really nice types that can be used for all sorts of musical activities, and we'll use one today that I have in mind, if it works, but we'll see. So the first thing that I'd like to do, let me make sure the microphone's actually working. All right, we're good. Is to go to freesound.org, which is our perpetual treasure trove of sounds. Let's type drone, see what we have. Nah, not really doing it for me for this. No, this looks good. Whoa, that's kind of cool. Yeah, I mean, the sound in and of itself, I'm not head over heels about, but as the author states, there's tons of harmonics you could even hear from there. That said, there's a bit of noise too, but maybe that'll be quite charming at the end of the day, or not, but we'll see. So let's copy that and get it into the system. So I'll do npm start to bring up a session. Sounds object from foldable. So we got, let's say my drone, whatever the URL is. I will have to do a couple imports to get it working. Assuming, yeah, that's turned on, which it is. And then this will complain because this needs to be a buffer URL. No, it'll complain about other stuff first. So we need to import that, and then the type of this needs to be buffer URL, and it says there. I love these error messages there, super useful. All right, so now we have that sound in, but we need to import the $. VS Code always does that. It launches this editor. I have no idea why, but it's fine. So we'll import the $, just by doing a generic import of the primitive. So now we have our sound in there, and we could even make sure it works by copying and pasting. I think it was 22 seconds, 31 seconds long. So let's put it at 31 seconds. Go to localhost 8080 and take a listen. All right, so we have it in our browser-based session. Great. And now what I'm going to do is what I've done in a lot of these, dip into the cookbook and just paste some DSP chain, sort of doesn't matter which one, but I'll look for high pass. Here you go, there's this exists, it's as good as anything, so we'll run with it. We'll certainly need imports for it, that's a given. So we'll just copy all these and then let the editor sort out which ones are relevant. All right, so now let's just remove all the stuff that we don't need, bam, and we have what we do, but it's mad about something. About that, interesting. So looks like that feature doesn't necessarily work all the time, but that's fine. We can just manually import a lot of this stuff. Calc slope. Hello. Okay. So now we have, well, let's just listen to what that does. It'll do something, but we'll change it in a little bit to be something a bit slower. Yeah, that's cool. Let's do something like way less dramatic than that. So low pass. Let's start it at like 50, something super low, and then plus calc slope. So let's have it going, I don't know, from 0 to 10 seconds. We'll have it going 50 to 1000. There's that darn editor again. Why do you launch 50 to 1000 as a function of clock time, but clock time mod 10. So we're always looping back to it. And let's make a pretty restrictive Q value, so we really hear it kicking in. All right, let's hear that again. We want this to be 50 F5. No, we want this to be 0 because we're adding. What am I talking about? And let's make this 950. That way we'll go up to 1000. 1000's arbitrary, but still. Cursed auto launching thing. All right. Back down comes from the modulo, which is not what I want to show today, but you kind of get this nice effect, don't you, from that. But what I wanted to show is something different, how to create a little piecewise function. So we'll use the same tone twice, but we'll create a piecewise function for it. So for now, so how are we going to create this piecewise function? Well, first, I'd like to create a map of just values in time. So we can say that, for example, at 0 we're at one value, at time 5 we're at another value, and just create it that way. So I'm going to say times equals map, or times equals array number times equals, so let's say at 0.0 we're at 2000, and at 5.0 we're at 1000. Sorry, kids screaming in the background. There you go. So here, so we have that. So how do we turn this into a piecewise function? Well, make piecewise. We're going to take our array. So basically we want to dial it up so that, like, as an example, if we're at 2.5, it'd be something linearly interpolated between 2000 and 1000. And let's just say that we're going to go back up to this again. 2000.0. So there, and then what we want is something that takes a number and returns a number. So it turns this into a function from number to number. It's a little clearer if you go like this, that we're returning a function. So we have an array of number to number, and then from that we're going to get a piecewise function, which is a function that takes a number, point in time, and spits out a value. So how are we going to do it? Make PW. So the first thing that I'm going to do is say as map equals map from foldable R, and what that will do, import data map. I'll call this a whole, I'll put where. So what this will do, as map. So this will create a map of numbers that point to other numbers. So I'm going to put low bound equals map look up less than or equal to n, where n is the input, and upper bound is look up GE. And why did I put new type in here? Because it's the VS Code autopilot thingy. I want to put n. Great. Okay, so now we have a potential lower bound and a potential upper bound. These are both maybes because we don't know if they'll exist. So what I'll do is pattern match on it. So val equals case LB UB of nothing, nothing. The trivial case, if it's an empty array, we're going to put 0.0. Just key value nothing is going to be the value. Meaning if we only have one value, then we take the value because there's nothing to interpolate. We need to put parentheses around it. Similarly, I don't even know if we need the parentheses actually. We're going to flip this around. Nothing, just key value. And then I'm going to say just key value, just key value. Let's put 1.0 for now, but we'll make it better. And then K0, V0, because we have two of them. So they need unique names. Key K0 value, V0. All right, and we need to import nothing, which we will. Why is it still complaining? Still complaining. Val equals case. Yeah, because I did not say what map we're looking into, but we're looking into as map. Then yeah, overlapping names in binder. So that means that we have something that is named the same thing down here. Let's fix it. All right, and now we should just get this whole back. All right, but here we want to calculate the slope of our interpolation. So we're going to do K0, V0, K1, V1, and N, the number in which case we have a val. Great. And we don't need this key, of course. So I've just made a little piecewise function maker using only pure script values, but don't take my word forward. So we're gonna now earth. Let's put fire here. Let's make this a bandpass filter. Bandpass. Let's keep the Q at 20, but the frequency is going to be our piecewise function. So I'm going to say make piecewise of times, and let's change times to times for bandpass, just to be clear that's what this is all about. So we make the piecewise function, and it'll be faster if I do it this way. So BPP equals make piecewise times for bandpass. And now we have a function, so BPP, and then I'm gonna, because that'll curry the computation so that it's done only once instead of every time the graph runs. Then BPP, clock time. There you go. And now we have that, and maybe the only thing that I want to do is map over this parse, and then map change volume const 0.2, just to make it a little bit quieter. Okay, so let's hear that piecewise function in action. And on kind of the upper thing, we should hear a dip down, and then something that goes back up if it all works. The low one's a little too present, so I'm going to put like 3 H's here, so which is the same effect as commenting out. Let's just hear the upper one. Too soft. 1.0. So it goes down, which we wanted, and then it goes back up. Great, so that's our piecewise function. Let's listen to it one more time, and it stops at the end, as we expected. So down, and then back up. But what fun is a piecewise function if it's as regular as that? Let's go to town and just put like a bunch of stuff in there. 7.5. Let's make it hike all the way up. Then let's say like at 15, we're gonna have a subtle dip down to 7. I'm clearly spitballing it. But then 15.5, we're gonna have a sudden jump to 3,000. It's like the cabaletta of our opera. And then we'll smooth back down to that. There's also a way to make the piecewise function looping, but for now, we're not going to. No, what am I talking about? Yes, we are. We're going to take this. So it ends at 20, and we'll just mod clock time that, and then we're good. Okay, and you can already hear it kicking in. It's a little soft though still. I'm wondering if I widen the cue. I'll start and stop it just because the cycle's so long. Going down. And there's the Cabaret, the Verdian tragic moment we were all waiting for. Hiking back up to that. Let's kind of make this a little bit more drastic. And now it's looping here, which is what I promised you it would do and what it's doing. Oh, cursed auto open. I need to figure out setting the VS Code to stop that. All right. Sweet. That's good. So now, without further ado, let's bring back in our drone. That'll be the overwhelming thing, but we'll still hear a little bit of color on top. I love adding tinks to this sort of thing. Earth, wind. Let's do tinks here. Tink 1. Like all my stuff winds up having these tinks whenever I'm dealing with drones for some reason. Make them a little bit more present. Yeah, that's kind of fun. All right, and now, not only am I a sucker for tinks, but I'm a sucker for changing their rates. What can I say? Old habits die hard. All right, so let's say cycle, normalize cycle time. Cycle time. 1.0 plus normalized cycle time times 1.5 normalized little cycle time because there's little and big cycle. Parse, why is it? Oh yeah, because we don't want to map, of course. Format this a little nicer. Alright, start and stop. Let's kind of speed this up towards the end. Let's speed up sort of pretty radically towards the end. So let's just really load lots of values towards the end. retweet it. Oh no, for what? Unexpected token, nothing. Uh-oh. Not fun. So there's some indentation error in here that I got to figure out in the pattern match. That's not cool. You know what? I'm gonna live debug this because I can. I need to fix that, of course, but we're gonna make this a little bit more organized. So maybe LB yoink, maybe UB, and we're gonna say 0.0 value. Then here, so LB has something, and we're going to say maybe LB dot value UB, and we're going to say UUB, and now we can do that. So there you go. Crisis averted, sort of. Still need to figure out why it's bugging out, but this will live to see its day on Wagpag, unless there's another bug of LLB key LLB value UUB key UUB value. All right, live coding is fun. So here, that should do it. And it did it. Alright. So the moral of the story is to fix this bug in Wagpad that didn't allow for that pattern match. Yeah, I don't know, there's little stuff like that. But if it gets in your way, you can just use these pure script primitives. Although that's no excuse, but for this session I'll have to do. And there's a sound on Wagpad, so it's done, man. Good, it's done. Alright, thanks for watching, and I'll see you the next time I make one of these.